We're done with Turtle Sim. We are leaving Flatland and we're gonna get some real robotic stuff done today. Alright, so I'll start by installing some stuff. Again, it's already installed on my machine, but on your machine it's not installed, so you'll have to do that. It's gonna take some time. Um, like I said, on my machine it's already installed, but on yours it's gonna take some 5 minutes to install, and it's gonna be a little slow. Alright, so once I'm done with it, I'm just gonna go, I'll just edit my bash RC script here. And you can see that I have added a line here, export turtle3 model equal waffle. Again, we'll talk about what all these things are in class. For now, all you gotta know is that we are installing some simulators and visualization tools for ROS, and yeah, from now on everything's gonna be 3D and physics accurate. Alright, so now that I have it, I'll run something. Now, this right here launches Gazebo simulator for Turtle3 robot. Now, Turtlebot is it's a robot that that's often used to teach SLAM and most of these functionalities for ROS and indoor robotics in general. Alright, so this is my Gazebo simulation. On your machine, it's going to take a little longer because I have run it once and I'm not using a VM. Again, when you run it for the first time, it's going to take some time, some 5 to 10 minutes, but once you run it once and you close it, again, don't close it here. If you do that, that's going to create some errors and it's going to take forever to load it next time. So whenever you want to close it, just press Control C. Okay, I'm just going to run it again. Like I said, when you run it for the second time, and from there on, it's going to run really fast. For the first time, it takes about 5 minutes to load. Alright, so this is my world, and you can see that I have a cute little robot over here. And this guy's got a camera, and he's got a LiDAR. This cylindrical thing you see over here is a LiDAR, and all these blue lines are, well, laser rays going off of the robot. And it does a decent job at detecting obstacles. You can see that my LiDAR is obstructed by all these poles and all these walls. Alright, and it has a range. It cannot go beyond 4 meters to 5 meters, which we'll see in a bit. But yeah, I have a robot here, and it's in a 3D little world, and I can simulate some physics accurate stuff here. Alright, in Turtle Sim we had a turtle teleop node. Here we need, well, a similar node to do a similar thing. So I'll just go here, open a new terminal, and Turtlebot ROS2 run, Turtlebot 3 teleop keyboard is the node I run to get my robot moving. Alright, I'll just minimize this one, I'll just make it a lot smaller, and if I press W, my robot goes forward, and if I keep it pressed down, it gains velocity, and if I press S, it stops. Again, if I want to turn, I would press A or D. If I want to go back, I would press X, and S would just stop it. Alright, so you can see that I'm scanning my environment with a LiDAR, with laser, but I'm not really doing any kind of localization or mapping here, which is something we will get to in a bit. Alright, so I'll just stop this guy here, and let's do something. Let's open a new terminal here, and I'm just gonna run another launch file, ROS2 launch Turtlebot 3 Gazebo. No, cartographer dot launch dot py use sim time. Okay, so I have some stuff going on here. What it essentially does is that it opens up ROS, which is not a simulator, by the way. It's a visualization tool for ROS2. Now, what do we have here? I'll just make this thing go to a side. I'll minimize my terminal. I'll make my turtle, my gazebo window go over here, and let's get our terminal here. And I'm just gonna drive around I'm just gonna drive my robot around. And as you can see, I have more data about my surrounding when I do that. And whatever my LiDAR sees is getting updated to my map. Now, what am I doing here? I have a bunch of topics that correspond to IMU data, inertial measurement unit data, LiDARs, whatever my camera sees, and everything. But what I'm interested here is that I'm just gonna drive around my room. I mean, by room I mean this little castle sort of thing where I have my simulator robot and I can drive this guy around. As you can see, my robot's moving here, and as it moves, scanning the environment. Now it collided with something, but you get the point. I'm mapping my environment with a LiDAR as I'm driving through. Now I have a map of my environment after driving around for some 10 minutes. Okay, so I'm just gonna open a new terminal here. I'm just gonna make a directory. Map directory. I'm just gonna save my map here before I close ROS. Run. Map server. And I'm just going to specify where I want to save the thing. New map. And if it doesn't run, you just gotta run it a couple of times and it eventually would run. So now, before we go ahead and do some path planning on the map we have created, we have to fix a lot of issues that the current version of ROS has. And for that, you have to install a bunch of extra functionalities. Before that, I'm just going to update and upgrade. After that's done, I'm just going to run sudo apt install ROS humble rmw cyclone dds cpp. Now this has to be added to bash, so I'm just gonna do that. Gedit bash rc, and on my computer it's already added, so you have to add these two lines. I think you have already added the first one, so yeah, you have to add this one too. Again, save your script and close it. After that, you have to go to this directory, pt ROS humble share turtle part 3 navigation 2 param. Now there is this file waffle.yaml. Now we need to replace something there. So again, we're not on home, so we're not in home directory, so you have to use sudo to edit any of these. sudo gedit waffle. I have already made the modification. I commented this one out, robot model type differential, and I have instead added this line over here. So make sure you replace the first one here, comment it out, and add this line exactly this line, robot model type nav2 amcl double colon differential motion model. Now at this point, what I would recommend is not just closing your terminal or sourcing bashrc, but rebooting your PC. Again, I have already done that, so reboot your PC, and assuming that you have already rebooted your PC, let's just go ahead and do some path planning. Once again, I'm just going to run ROS2 launch turtle bot 3 gazebo turtle bot 3 world launch.py, and that's gonna launch my gazebo simulation. Again, this is something we have already done, so why am I doing that again? Well, this time around we're not gonna drive it, the robot's gonna drive itself. For that I have to run ROS2 launch turtle bot 3 turtle bot 3 navigation 2 navigation to launch.py, use sim time colon equal true. Map, where did we store our map again? Where was our map again? Map directory, right? So new mapdir and new map.yaml. So I'm just gonna add it here. There shouldn't be a space here. It's gonna take some time, but it'll work. And here we have ROS, and this is our previously stored map. It's the map we saved, and here we can do an awful lot of stuff. First of all, we're gonna set the origin. Again, in my simulator, the robot's over here. That is the origin for this simulator. So I'll just set the origin in my ROS window. Force estimate. I'll click and hold and then point towards the direction in which my robot is facing in Gazebo. So that's that, and you can see that it did something here, right? That created an occupancy grid here. Now this controller, or my local planner, if I turn it on, you can see this thing reappearing, and here I have my global planner, which takes into account the entire map and plans accordingly. Now there's a really cool feature here to do path planning. I'm just going to click on nav to goal, and I'll just click on a random location in the map, and you can see here that my robot is automatically generating a path and following it, and whatever you see on ROS is going on here too. Now this doesn't really have to be Gazebo. this could be a real robot. That's the best part about this simulator.